Hi, I wanted to share some insights about the PCA in case it helped to better understand what is the purpose of PCA and how it works with the original set of features. What is the situation here? The input vector that you have is it's formed by a matrix of m rows, right, and p predictors. This is the number of features that you have in your input data set. And you want to reduce the dimensionality of this. So the final goal is to produce an M set of rows with less than P predictors, right? When you apply PCA to the input vector X, to the input matrix X, what you get is another matrix, which is P rows by P columns, and these are the principal components, right? Only the most important ones are those that we are gonna get. So the number of columns that we are getting from here is lower than P. So in this case, suppose that we are taking only the first two, right? So by applying this transformation, multiplying the original data set by only the two first principal components, which is only two vectors of length P, right? What we get is a matrix multiplication of this shape. The original data set is m rows by p columns, and we are multiplying this by this other thing, p rows and only two columns, because we want the final data set to be shaped or transformed into a two-dimensional space. And the result will be an m rows by two columns data set. This new data set, is the one that is in a lower dimensionality and the one that you need to use in your classifier if you want to work with a lower set of dimensions. And the features that are in here have nothing to do with the original one, so you cannot infer that these two columns in this data set represent any of the features above or in the original data set. No. These two new features are a projection of the original ones into this new space. So let's try to produce this and plot this to see if this is representing the original data set, and you can perform a classification in this lower dimensional space. Let's try it.